make a video on divisibility rules, and what this really means is how do I know if a number can be divided by 2? And so if you take a look at these two numbers, 386 and 683, you might say, well, one of them can be divided by 2 and the other one can't. And here's how you know. If a number can be divided by 2, the last digit, the one in the ones place, must be even. Well, even numbers are 0, 2, 4, 6, and 8. So this number 6 is even, and this number 3 is not. So therefore, I could divide 386 by 2 and get evenly. All right? Moving on. So that's it. Last digit must end in last digit ones place must be even. So that's pretty easy to understand. The 3 is a little bit more tricky to understand, but it's actually not all that bad if you look at some patterns. So I'm going to just put in some numbers: 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33, and 36. So I just want to show you something real quick. If you were to add 1 plus 2, you would get 3. If you were to add 1 plus 5, you'd get 6. If you were to add 1 plus 8, you would get 9. And this happens to be true for all numbers that are divisible by 3. If you can add their digits, and the sum of their digits is 3, 6, or 9, it is divisible by 3. So 21 is 2 plus 1, you get 3. 24 is 2 plus 4, you get 6. And 27 is 2 plus 7, you get 9. 3 plus 0 is 3, 33, 36. 3 plus 3 is 6, 3 plus 6 is 9. Now you might have something like this. 99, and 99, 9 plus 9 equals 18. But if you take a look at 18, 1 plus 8 equals 9. So therefore, 99 can be divided by 3. Add digits, and if the sum is 3, 6, or 9, you can divide by 3. All right. Now, I'm sure you probably know the rule for 5. And the rule for 5 is pretty simple. If you look at the numbers 5, 10, 15, 20, I'm sure you'll notice that the ones digit must be a 0 or a 5. And if it is, then you can divide that number evenly by 5. Well, 9 is a special case because 9 is really 3 times 3. So the difference is 9, 18, 27, 36. Here, when I add my digits, you get 9. 9, 9. And once again, we know that 99 works. 99 works. But 99 becomes 9 plus 9, which is 18. And then 18 becomes 1 plus 8, which is 9. So the sum of the digits must add to 9. So it's very similar to the 3. Now 10, you might say, oh, well, that's easy. 10, 20, 30, 40. The ones digit must be a 0. But there's a special reason for that, and I want to make sure that you understand this. The reason why is because 10, the number 10, is equal to 2 times 5. So if a number is divisible by 10, that means you have to be able to divide it by 2 and 5. Well, look, in order to divide by 2, it has to be 0, 2, 4, 6, or 8. And in order to divide by 5, it has to be 0 or 5. Well, here's the problem. If it ends in a 2, you can't divide it by 5. Yeah, and if it ends in a 4, you can't divide it by 5. If it ends in a 5, you can't divide it by 2. So the only two numbers that overlap are the 0. So that's why 10 has to be divided by, the last digit has to be a 0. And there's one other one I want to show you. 6 is equal to 2 times 3. That means that the last digit must be even, and the sum must be 3, 6, or 9. So, for example, I know that 66 can be divided by 6. And that makes sense because the last digit is even, and 6 plus 6 equals 12, and 1 plus 2 equals 3. So it's divisible by 3, and it's divisible by 2. Alright, so that's that. I went through this pretty quick, but it's something worth knowing, and you'll use it when we're doing prime factors.